Hello and welcome to this electrical domain session as part of the buildingSMART International Standards Summit, Lillestrøm 2023. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled TecBox IFC for Electrical. The speaker for this session is Bernd Gmeiner. This session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speaker, I would like to remind you that this is an hybrid event. For online attendee, your microphone will remain muted for the duration of this session. If you wish to make any comment or ask a question, please use the chat box in the control panel. For the attendee in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would like also to bring to your attention that buildingSMART is committing to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, no binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Bernd.
Thank you, Laura. So, my name is Bernd Gmeiner, as Laura already said. So I'm, also in the steering committee of the electrical room, and within buildingSMART, I'm also in some other working groups like IFC for Lab and Open BIM in industrial planning. And what I like to present today is an approach, we call it the TecBox, which originated in a joint working group between buildingSMART Germany and the International Association, Laboratory Association Egnaton. And the focus was in the beginning on laboratory trades. In the beginning, it was just meant to be kind of a bounding box collision body to have some geometric space properties and technical information inside. But then we saw, okay, it makes sense that you can have an interconnection between different spaces, so that you say you have some information interfaces you can use for in a connection with other objects, and in a very early phase in a project. And that's how the story began. And then we also figured that it makes sense for other MEP trades, so mechanical, electrical, and plumbing, that there's sometimes interactivity necessary, also a common understanding without having a detailed view on the objects, because the HVAC people maybe are not so deep into the electrical stuff and plumbing and vice versa. So it made sense to have such an approach. And also the idea was that you have the possibility in a very early stage of a project to do calculations, for example, on, if I stay with HVAC, on airflow. You don't know at that point what exactly the components are in the beginning of a project, but what you already know is, I mean, what can you do with that building? There are some limitations. So if you want to do calculations in the beginning of a project, then it's, I think, a good way to have some placeholders with information that will be later on in the content of something like that. But I try to get an easier analogy for that. I'm coming to that in a next slides. So what does a TecBox do? It organizes within an IFC file the structure of the entities that are in there. So it aligns metadata 3D models, documents, and so on. And the important point is, it aligns that information to a special role in a special phase of a project. So the problem was always that people get too big IFC files with every detail in it, which most of the roles don't need. And the only thing that happens is that the software or a laptop, whatever, breaks down and you cannot work with that. So you need the information more or less specially prepared for your activity. So you can say in a nutshell that the TecBox approach also can boost the LORN, so the level of information need approach within the electrical trade, which is very important, as we will see in the next slides. And just as a note from the side, so the word TecBox is a working title. So it not only has to be a physical box object, it's more an information container. We will see that later, just to make that clear. And as I mentioned, LOIN, or LOIN, or level of information need, just a quick slide to that. So if you look at top, what we had in the past, or a lot of people are still using it, LOD, level of development, level of detail. There are a lot of words for that. It's difficult if you say you have LOD 200 or 300 or 400. What is that? I mean, for example, if you look at HVAC planner, maybe this person just needs LOG, so level of geometry 100, just a box, because this person is not interested in any tiny little things. But this person needs LOI, so the information metadata, on a level 400. So what do you do then with LOD? So I mean, there are different other examples here, like electrical planner, system integrator. So there's always a different need, and that's why the level of information need concept makes sense. So you can decide which metadata you need when, at which phase, which documentation you need, and also which level of geometry you need. And I think that's some of the most important thing about level of information need. And just first, before I dive into the TecBox, some analogies. For example, imagine container ship, something like that. So you have different containers to place. So they have different sizes and so on. But normally you would think, yeah, that's easy. So just, you do collision detection and place them where they fit. But in reality, you have some things like dangerous materials in there. You don't know exactly which one it is. You just know it can explode, or it has acids, or it has or danger for biological beings, whatever. And if you add such information to a container on a ship, and then you know, oh, okay, there are some containers that should not be close to each other because nitrate and something else, like there were also some things that happened in the past, I think. So if they are too close together, something gets wrong, this whole thing is on the ground of the ocean. So this would be good to have this information before you place the containers where they should be. So that's maybe an analogy for a ship, or you can also go, look at the airport, that you say, okay, you create, or you want to build an airport, what the space would be for the planes to dock, for the people to go in. And then you can create some kind of a bounding box that you say, okay, no way that there ever will fit Airbus 380 in it, but maybe there are a list of planes that would fit into this box, and you also add maybe some entrance points where you say, okay, our this stairway where you could place to the plane. So we are also limited in the angle. So there's also maybe some planes you cannot dock at this position. So maybe it's also an analogy what a TecBox could be for. But for the lab, I just bring it up quickly. I know it's not a topic, electrical, but you easily see that such a laboratory bench has a lot of not complex, but a lot of different objects, let's say it this way. And which supplier you use, what exactly installed there, you know, really later in a phase or in the project, not in the beginning. But still, what you know is there's an HVAC connection, there are electrics, there are medias like gases, fluids you have to use in this. So in the beginning, you just create something like that, a box, but with an exact position where the HVAC system, for example, will be connected to that box. And if you do that, then you can, for example, create a complete storage of this story of this building and say, okay, now we can make calculations before we even know who will be the company we ask for IFC models to put in. So it's very efficient, and you get around a lot of problems, at least in laboratory projects. And later on, you can fill that boxes with TecBox content step by step. Similar topic we have in a group that's called Open BIM in Industrial Planning, where we said, okay, you have production lines. The production lines have maybe some dangerous parts in there, robots, whatever. So there's some specification you put on this space. And also you want to place smaller production lines maybe within this whole line. And then you also have some properties that collide maybe with the intentions you have with another production line. So you cannot just put any kind of purpose into that. So that's also used in another working group. And now coming to our main topic here, the electrotechnical trade, there's a lot of opportunity to use an approach like that. For example, if you see that, I mean, it states it's a trade within a building, that's right, but sometimes you have a complete campus, sometimes you have also buildings that are somehow connected. You also have maybe power generation on site. I'm not talking about, you know, a big power plant or something. It's really like what you have on the roof, for example, or maybe could also be wind power. And so we are talking about medium voltage power distribution, low voltage power distribution, and low voltage final distribution, so the complete chain, as well as the electrical network around it that fills the building with life. So the blood pumping through the whole building without power in your music. So that's what this is about, and how to use the TecBox in that context. I said in the beginning, the TecBox doesn't have to be a physical related object, a bounding box. Can be, but doesn't have to be. It's an information container. So for example, you say there's only metadata in there in the beginning, maybe some specification, some rules, or some standardization document, something like that. So that's also possible. Later on, then you can have also 2D models in there, or 2D drawings, metadata, and documents, or it can also include 3D models, which are, that's why it's transparent, but I come to that. So within such a TecBox, there can also be a 3D model connected of different level of geometry. Just to I don't want to go into detail, but just so you know, the roles we defined in our room here are architect, electrical planner, so EPC, so or EPC, so general contractor, non-electrical trades, panel builders, which is interesting because then that's, for example, a role that needs very specific and and high resolution objects. Operators, service providers, which is interesting when we talk about digital twins or think about digital twins, and in the end, the demolition contractor. And yeah, these are the roles we were thinking about, and of course the phases. Let's start with the highest level of the TecBox we thought in the electrical room. So we call it solution. So the solution is more or less kind of a map or a holistic representation of the whole electrical system. It doesn't maybe need to have specific systems or switch cabinets, something like that in place at that point. It just says there is a electrical network that is somehow defined where the energy has to flow, and what you can do, and that's, I mean, the idea behind it, that you say, okay, you have a seamless integration that merges electrical lines, transit paths, or plumbing, water supplies, so that you can make clash detection very early in the, and you also are able to make maybe some calculation. I mean, that's the aim we have, that you can also do a lot of maybe some simulation where it makes sense in the beginning before you even know what the exact products will be. And later on, the same thing could be used as a kind of raw model for a digital twin in operation. So maybe you're not interested, depends on the system, of course. Could be building management system, production management system, whatever. They only need to know what the electric network looks like. And still, if you have that right from the start, you can also have validation in the end, so that you see, was that what we have planned to be, without including all these tiny, big data objects. Then below, we thought about a TecBox we call system, which also has a hierarchy inside. So you have a system, could be like this, a switch board, switch cabinet, as you like. Below that, there is a subsystem. You have a component, you have components, and you have products. What we see behind that is in the next slide, so that we say, okay, the TecBox system, so you don't have a kind of a separation of the, separation of the cabinets or columns. You're not interested in that. Maybe it's the architect. He says, okay, I'm interested. What is the total weight of that stuff, including what will be inside? I'm interested in the maybe material, the dimensions, also interesting for the HVAC planners. So is there enough room on top to get rid of the hot air, things like that. So you can do some calculations only with that. And you can also maybe do adjustments if necessary. For example, what's often forgotten is that this thing comes often pre-produced. So how to get it in? So it comes with a pallet, maybe to move it, and it has some other stuff to keep it in place, to have it safe if you transport it. And then if it doesn't fit through the doors or whatever, so maybe it's good to have an idea in the start of a project how that system would be like, even if you don't know the tiny little things. So the next would be then the subsystem. Interesting about that is because I said the TecBox is an information container. So of course, physically, it could be inside the system, as the name maybe makes you think of, but it can also be outside, because maybe it's just hierarchy. It could be a junction, whatever, junction box, which is outside the system, but still it belongs from the hierarchy point of view to the system. So that's also possible. And that's the good thing about the TecBox, that maybe it's not physically connected or housed, let's say it this way, but somehow connected. Then if you go to the component, component would be something like an assembly of different products that together have more capabilities and features as each product alone, to say it this way. And as this is maybe very complex and even at some point the electrical planners are not interested in these tiny little things, they just want to do their job, they just need to know what the features are and what is expected. And after that, then you look for a supplier who would meet that specification for such a component. So you only talk, or it would be enough to talk about the interface information connected to that component. And last but not least, the heart of the TecBox hierarchy from a physical point of view is the product itself. So normally a product like this has a order number, something like that. That's kind of maybe a criteria to find out what the product is. But as there are often discussion, what is the difference between a product and a component? I have a slide here. So just to give you a quick overview what the difference is. So you say you have, for example, a power switch, which is a single product. But if you need some more specific features or capabilities to it, what do? You add accessories, maybe some special sensors or whatever to enable the power switch to do more than just on-off. And once you do that, then of course this component or TecBox component has some different information, like the weight, of course, because there are more products in there. So there's a special weight, but then you also want to define, oh, there's a maximum weight. We cannot put anything in there we want. And also the space, for example, if you have products that also produce heat on its own, then you need to have spacers in between, something like that. So there's a good reason to do something like that. And if you see the component within, for example, a cabinet or a column or field, whatever you want to call it, then there's also something maybe in between that you say, I cannot place it anywhere. I cannot place it maybe in this cabinet, because there are some rules already inside this TecBox that doesn't allow that. And also coming to when I talked about level of information need, the documentation, what you also would like to do maybe is, for example, for a system. So the TecBox system, as I showed, was the switch cabinet, for example, or level higher, the solution, where you would put power diagrams. And through the success, or through going through the phases of the project, you need different power diagrams. So you start, for example, with a block diagram, then razor diagram, single diagram, and so on and so on. So you can define at which phase, which role needs which, or should at least have, let's say it this way, at least have which diagram type you should add as a link to the TecBox, which is inside the IFC file. And as I said, TecBox is an information container. The good thing is it doesn't have to be a 3D bounding box. You can also open a single line diagram if you have a software tool that can, for example, show, there are, for example, here, there's a component, the power switch, for example. There's in IFC, there's a class for that, entity. And you know, okay, in that case, even if you show it as a diagram, you know, okay, here is the system main power distribution. Here is a component. The transformers are systems. So you can also use the TecBox in 2D. There's no reason why not to do that. And if you go deeper, because I said everything is connected, exchanging data, how is that possible? I mean, there are a lot of things already in IFC that you can just use to make it happen, to bring that together. For example, here, we were thinking about connections. So what we need in the electrical room are, of course, electrical connections. Could be bus bars, copper bus bars, could be cables and so on. Data connection, cables. But, and here comes the point, data connection can also be Wi-Fi. And if I talk about Wi-Fi, you cannot touch Wi-Fi. So you have to have some idea how to also represent that properties in a data connection if you are not using a cable. And that's what you can do with this TecBox approach. And then you have mechanical connections like things you don't need to show in detail at all. Cable trays. Okay, it depends on who the role is. Maybe some would disagree that say, okay, we need to exactly define where the cable trays are and the screws in the wall for the cable trays. But for electrical trade, it's not that important. We just need to know where the power line will be. And also mechanical connections could be inside a cabinet, like things that hold everything in place. How do we do that? We have something that backs our approach up. It's called ISO EN 19650, where there is something in that's called functional federation strategy. I don't want to go into detail, but you can read that if you like. But what it says is following, that you have intersecting components, maybe mechanical or electrical system. That's what's in the DNE and ISO 1950. How do you solve that? With this federation strategy that you say, okay, we have highest level, we have all containers federated information model. So like solution or system, there's kind of inherits all the information down there and brings it together. So maybe the complete weight of a system, something like that. But then it says the container can also be separated, for example, for architecture or for MEP and so on. And that's exactly what we did with the TecBox. So we have the TecBox structured in a more physical, from a more physical point of view. But what we do is we connect a TecBox through, I come to that later, through use cases to a special role. That's exactly what's happening in ISO 19650. Talking about use cases, also interesting. What's also in this ISO norm is, how do they define a use case? How does buildingSMART define a use case? How does this work together? It's very easy. So you have, in the ISO, you have a workflow view. So it's a process, and a process has activities. And once you go into detail, you instantiate this, and then you have a process of a maybe special phase and so on. And on the other hand, you have the use case view. So you have a function like planner, and this person has a task once you instantiate it to a special point in time. What else is this? The workflow view is our BPMNs we are using, and we are using in this room. And the use case view is nothing than a use case description. So we are also aligned with the ISO 19650 already. What did we do with the use case? What was the approach in our room to define or to break down a use case that has special needs and requirements? So what we did, we showed it also some time ago. This is the complete BPMN of electrical trade, or a process of a project that's focused only on a few of the electrical trade. So you have the rows in the swim lanes I already showed you. These are the phases, the 11 phases we defined, which also includes operation and demolition. And we defined for each role the activities as well as an outcome for each activity. So if you have something like that, and we discussed a lot to get that view, if you have that, then you just pick something out. Maybe this phase. And as you can see, that's what we called use case 2.6. We will elaborate this not during this event. We're doing that later, but we're very close to finalize it. So the use case for us are these two activities. And that is, in phase 5, the electrical planner refines the distribution network planning and integrates the result into a collaboration model. And that's the requirements we were discussing for this use case. And we also want to describe, or we already did that, what are the metadata required for that, what is the geometric information required to do that, and what is the documentation required to do this use case. And during this event, often I think this topic IDS popped up, information delivery specification. I mean, it's not very far away that you say, okay, we want to use a TecBox very early in the process to do simulation work or calculations, something like that. But somehow, I mean, it adds a little more complexity to the whole idea of BIM, maybe to define it. Once defined, the process is much more easier, quicker to do. But how do you do that? Where's the point where you say, what has to be in this use case? What is the information that's in there? What's the geometry, everything? And that's the way where we thought, and that's it's new in our TecBox approach, that we say, okay, once we have a use case defined, we have all the properties we need. Why not go there and say, okay, we just produce an IDS, if, of course, only if that use case happens 10,000, 100,000 times a year in this industry. It's always the same. So why not create an IDS from this use case? So you can have a seamless integration of all the processes coming later. And before, you can also switch forward, backward, and so on. If you define that's a use case, because maybe there's some alignment necessary anyway. So we can do that. So you have, you ensure data integrity and consistency across the life cycle. And that's, I think, an approach that's worth looking into. That's what we're doing now. And later on, and it comes, of course, also to digital twin. So you can also cross-check, was that what was meant in the beginning? Is really all information in there that I need to have in a living digital twin or industrial metaverse, however you want to call it. The information is the same, so someone has to define it in the beginning. And I think there's a good chance to do that with IDS. I mean, we jumped onto that and had some thoughts about it. And that's really just a quick excursus to how we would use an IDS. We discussed it a lot, so that we say, okay, you have, that's a BIM project, where, oops, very rough. You say there's the project start. Then in the first phase, you create the exchange information requirements with all the stakeholders, and you can choose already an IDS, which is a use case that is defined from, for example, a domain that you could maybe, it's maybe standardized and you can just pick it, but it's not forbidden to create your own, but then you're somehow closed in this project because you will be the only ones to use it. And once you do that, you can, for example, the architect creates an IFC file, which uses the IDS as recipe. It's like a cooking recipe what you're using. And it's just the minimal requirements. You can add what you want. and then it goes on. So in the next step, it's developed further together with another role. You create another IFC object using the other IDS. And what you also can do, of course, you don't have to use one. You can just create your IFC file as you did in the past. There's no bad thing about that. But the important thing is that once you created that on kind of a recipe, later on, when it comes to the clash detection and verification, you would use that IDSs to verify your IFC files based on the recipe. Or if you don't have a recipe for it, then you use it. You use the verification like you did in the past, and that's more or less how we would use the IDS in our electrical domain. Now I just have to dive deeper into the connections, because I said I talked about the federation strategy, but it's very theoretical. But how do you do that in IFC? And the idea here is to say, okay, if you need components connected, for example, on a higher level, the complete building, you see the electrical routes and so on. So there are relations between the stories and the cables and so on. Or you go a step deeper, connecting systems. For example, you have here the medium voltage system that has an electrical connection to a transformer system that has electrical connection to a low voltage system, and here are very rough some consumers, which would be motors, for example, and there you have an electrical connection and a data connection. So you can also do that with a building management or production system. There also you have data connections. And you also have some mechanical connections, what I said before, the cable trays, or inside a switch cabinet, there also you have some connections. You're really not deeply interested in how it exactly works. You just need to represent them somehow. The idea behind that is that you say, okay, you have, for example, a final distribution board, and with all that information given in these TecBoxes, you can easily work together with the security people, the fire safety people, the lighting, HVAC, and so on. So everyone understands through these boxes and the information given there what is needed. And by the way, so are there some questions? I'm just jumping over all that. So because I would just go into some details what you can do. It's only a few slides anymore. But are there some questions at that point of time?
Thank you very much. It's working. Okay. You were talking in the beginning about level of information needs and then about the systems. Are they somehow connected to each other? So with the system, component, product, and so on. First question, second question. Are you considering also, you mentioned that you're not taking geometric, it doesn't need to be geometrical. But probably some semantical information. Yeah. Are you also tackling some uncertainties, if it's geometrically or semantically, in this TecBox approach?
Yeah, the thing is, like for example, you structure, if you have a structure of an IFC file, you also have hierarchy levels in there you don't use. There's a given structure for an IFC file, and depending on the domain, and then you put in data if you have the data. If not, it's empty, but still the hierarchy is there. And the idea is also with the TecBox. The hierarchy of the TecBox is always in there, always. If you don't fill it, it's fine. And that's also the connection, I think. You see, so it's automatically connections if you fill the file. Yep.
Yeah, Fabiana von Gober. And I have a question, because I see, please, maybe I don't understand it very well, but you use systems engineering to define the box. And then you put it in IFC to digitalize that. And then I understand that you, in the transactions on the process, then you define what is not there. And then, through the process, you define what is missing to build maybe an IDS at the end. I understand it very well.
Okay, I get the point. No, the idea was from the IDS, we create the standardized IDS idea. We create in this room or in this domain. It's different to the project itself. The project owners would be able to use the IDSs, the domains produce if they are standardized. But it's not forbidden to create your own idea or specification, I guess, your own specification. But once you do that, you are, I mean, not really closed BIM, you're still using IFC, but no one else would know what you're doing with your specification, because you would only spread it around in this group of people working in the project. But the idea is to have kind of a blueprint or kind of a raw model you could use to make your work easier. That you say, okay, I'm this process step, I have this role, working together with these people. Already someone created such a specification you could use to go from that point to go further. But then you already have it. And that's maybe the idea. I don't know if that answers your question.
Maybe I can give you an additional information to your question, if I understood your question right. Yeah. So the TecBox system is just a structure to structure a complex system, like a power distribution network in a building. Yeah. And the IDS is a description for a use case, which you will do with a structure or with the equipment. Okay.
Yeah, maybe also my view to the TecBox is that you have a kind of a 3D information cube, like a Rubik cube. Depending on the job you have to do, level of information needed, you turn the cube that you get exactly the geometry information, the level of detail and all that stuff that you need to do your job. And maybe some other people, they have to do a different job. They turn the cube into another, let's say, position, and then they get their information. And everybody has the information he really needs to do his job at the end of the day. And based off that, out of that, you can also create then your ideas.
Yeah, so based on the physical objects, yeah, completely right. If it comes to the connections, maybe we have to add some layer to that, but I come to that. But definitely, yeah, when it comes to bringing for example, take the switch cabinet consisting of 4 columns. So if you say you have different, let's say, a different purpose for each of the column, and then you say, okay, maybe now it makes sense to switch them. So because given the information in there, maybe that could be an analogy to that, what you're saying, Christian.
Oh, sorry, Christian. We've got a comment from Bernd saying that maybe we can say that TecBox is just a way to use the existing IFC system and standards, and not something new and additional.
Yeah, that's a good point from Bernd, because you're using an analogy which somehow makes sense, but if you like Bernd says, what I also said, if you come to the connections, then you need to add a layer to that. So maybe you have different Rubik cubes, if you like, and you need to connect them. But for the cube itself, if you say it's a special kind of trait, then maybe this view is really good to use. Because my next slide is not so many anymore, but not so many, but then I would go into that relations, then maybe you see what the idea is behind that. Okay, so these are the TecBoxes so far we're thinking about. So solution system, subsystem, component, product, the connections, and something else we I will just, talk a little bit about it. It came also from the Open BIM in industrial planning, which also makes sense in electrical trade. How can this be done? Really, just on this slide, I just want to get a few steps back to IFC. That if you say, okay, from a functionality point of view, if you have IFC wall and you have IFC window, you just say, okay, there's a relation because I want to have a window in a wall. The next step, you have to think, how do I do that? So from a schema, I need a objectified relationship between wall and window. And I'm showing that because I'm saying it's already in IFC. There's nothing new to develop. It's already there. And then modeling in IFC, then you say, okay, IFC wall, these are the relations then, and I have IFC relation voids element because there's a hole I need. And what do I do with this void? I fill it. So the IFC window is, I have a property, IFC relation fills element. So, and that's where the thing gets together. What we don't have, for example, in electrical trade, that you say, okay, you have something that delivers power, a feeder, there's a consumer that needs power. But somehow, it's already, the concept is there in IFC to deliver exactly that, to have connections, data connections, and there are also a variety of classes and entities in IFC. It's just there to be used, and that's what we need to do. And that's my last example, that you say, okay, imagine that an IFC file structure. So system A is a switch cabinet, system B is also one. So, and as you see, everything is empty in the start. There's nothing in there. You could put in there properties, geometry, or documents, but maybe it's empty. And then you say, okay, we know that there will be a connection between these two systems. We even don't know which one. We just say in the IFC file, hey, there will be a connection. There's a property for that, to say that, or an entity relation. And then you get a step further. Then you say, okay, now we know it's a subsystem that has an electrical connection to another component in the other system, and it has also a data connection to this component, and so on. And so you can, through this kind of connecting objects, or in that case, TecBoxes, you can easily also do some calculations with that, or simulations. And then there came the question, how can I instantiate that? So that I say, okay, I have special motors, for example. It's also easy then in the IFC file, you say, okay, the subsystem the system one has a gateway, it's a product that has a data connection to motor 1, motor 2, and as many motors as you like, as well as many connections as you like, and the same with power. So you can do that very easy. And by the way, that's the use case we are now doing. So we are creating an IDS file, an IFC file filled with that information we described in our use case, and even a 3D object, so a finalized IFC file. We're working on that. And just last quick word about the TecBox used as functional cluster. You can also say, and that's really beyond maybe electrotechnics and so on, that you say there is a function, a purpose that these elements have together. That's information maybe not interesting for a lot of the roles inside this project, but maybe for a plant planner, engineer. And then I know, for example, that I have some components already in the TecBoxes, and I add another TecBox which says this is, for example, so this function means that the motor starters will start and control the motors, and that's kind of a function I could also display then in an IFC file with that method. Okay, so that's more or less in a nutshell our approach and how we try to connect it to the electrical domain. Are there any other questions? I think this presentation is also online later, and so if you want to talk to us, just contact our room, or also my name and address is also in the presentation. Thank you.